Alright, so today we're going to do Unit 3, Day 4. We're going to look at triangle congruent. We already know that two figures are congruent if their measures are congruent. The only thing we've talked about so far being congruent has been segments, which only has one thing to measure, right? How long is it? And angles, which only has one thing to measure. How many degrees open is it? Okay? But in a triangle, we have a lot of things we can measure. Do you remember we've talked about it? How many things are there to measure on a triangle? Sides and angles. How many sides do I have to measure?
3.
How many angles do I have to measure?
3.
Which means there's 3 sides and 3 angles that can all have a value. So there's 6 things to measure on a triangle. In order to say those triangles are congruent, all 6 of those things, we have to be able to show that they're all congruent. All 6 things have to be congruent in order for the triangles to be congruent. Okay? So, for example, when I look at these two triangles, I can tell the angles are congruent because they have matching arc marks. So, for example, I can see that the measure of angle A, or angle A, is congruent to angle. Now, A has one arc mark on it. So, which angle does it match with?
R.
Angle R. Okay? Then, I can look at angle B, and angle B has 2 arc marks on it, so angle B is going to be congruent to angle S. Angle C has 3 arc marks on it, which means it's going to be congruent to angle T. Okay. Then we can also do the same thing. So those are those 3 things, but I said there's 6 things that have to be congruent. We also have to show the sides are congruent. So I can see on my first triangle that I have this single tick mark on AB. So segment AB, it's a segment, has endpoints. So we write it as a segment. Notice I'm using all capital letters because the vertices of the triangle are points, right? So segment AB is congruent to, which segment does AB match with? RS. RS. Okay, so then I can look at 2 arc marks, or sorry, 2 segment tick marks, and I can see that AC, segment AC is congruent to which segment? RT. And last but not least, BC has 3 tick marks on it. So segment BC is congruent to SC. Segment ST. Okay. So the next thing we're going to learn is a congruent statement. And today we're just going to, well, from now till like February, we're going to work with congruent statements with triangles, but you can also have them with quadrilaterals and hexagons and all the things, okay? But we're just going to focus on triangles today. A congruent statement is a statement that says 2 triangles are congruent. At the same time, it shows you which angles and which side are corresponding congruent parts. So let me show you an example of what a congruent statement looks like. It says 2 triangles are congruent. So we're going to name one triangle. So I use the triangle symbol, just like before an angle, I use the angle symbol. Just like above a segment, I use a segment symbol. In front of a triangle, we use a triangle symbol. And then you use its 3 points, its 3 vertices to name it. So if I want to name this first triangle, I can name it triangle ABC. I don't have to go alphabetical. I could call it BAC or CAB, whatever I wanted to call it. Okay? And we're going to say this triangle is congruent to triangle. Now, it says that the statement says two triangles are congruent. So triangle is congruent to triangle. At the same time, it tells me what angles and what sides are corresponding. So I have to make sure when I write my second triangle, the angles and the sides match up. So if I start with A from my first triangle with the single arc on it, where do I have to start from the second triangle? R. And then from A, I went across the single tick mark to the double arc. So from R, I have to go across the single tick mark to the double arc, and I end up at S. And then I lastly end up at T. Triangle ABC is congruent to triangle RST. And it's really easy to look at that and go, oh, okay, angle A and angle R match. Angle B and angle S match. Angle C and angle T match. But you can also, it says, use it for the sides. I can tell that segment AB is going to be congruent to segment RS because they're the first two letters. Okay? And I can also, that's what we found, right? The second two letters, BC and ST, those two sides will be congruent. And then to figure out what my third sides are, I look at my outside letters, AC and RT. AC is congruent to RT. So even if you don't have a picture, if you're given a congruent statement, you can tell what all matches what. Okay, you can tell what matches what. And because we're using this to figure out what matches, order is going to be what? What's important? Order. Order is important. What's important?
Order.
Order is what?
Order.
Awesome. All right, so it says write a congruent statement if possible for each set of triangles below. So remember, we have to show all the sides are congruent and all the angles are congruent in order to know that our triangles are congruent, and then we can write a congruent statement. Nothing tells me these triangles are to scale, so I can only trust what I can see mathematically in the picture. Okay? So if I ever say, well, it looks like those angles are the same, then that's not right. If I say it looks like those sides are the same, that doesn't work. Okay? When I look at my first two triangles, can I show all three angles match and all three sides match?
Yes.
Yes. So I can write a congruent statement. I get to pick the order for the first triangle. And because I'm boring, I'm just going to go with ABC. Is congruent to triangle. So if I started at A, where am I going to start in the next one? J. And then from A, I went across to B. Where am I going to go from this one? K. And then I'm going to end up at L. Now notice I can just trace my triangles and they match, but be real careful because sometimes your second triangle has been like flipped or rotated or reflected. So make sure that you really are matching up the markings. Okay? All right. What about this one over here to the right? Can I show that all three sides match and all three angles match?
Yes.
I heard a no. What can't I tell? The angles aren't marked for me, right? One could be 45 and 45, and one might be 30 and 60, right? I know I've used 90 degrees out of the 180, but I don't know how the other 90 degrees are distributed in each triangle, okay? So I have all the sides, but I only have one angle, so this one I'm going to say not possible. Today, anyways. On Monday, we might have some new tools. All right, the next one, these two triangles, my left and my right triangle that are attached at BC, can we write a congruent statement for those?
Yes.
Yes. I can see all three tick marks, 1, 2, and 3. 1, 2, and 3. I can see all the arc marks, 1, 2, and 3. 1, 2, and 3, right? So I can say triangle. What do you want to call the first triangle? BAC?
Yes.
And we're starting on the left side then, if I go BAC, okay, is going to be congruent to triangle. So the B for the left side triangle has 2 arc marks in it. So where am I going to start on my right triangle? C. And then from B, I went across the 2 tick marks out to the single arc A. So from C, where am I going to go? D. And where do I end up at? B. All right. Questions on that one? And again, you can do the different order on the first one. If I did A, B, C, then this one would be D, C, B, as long as everything matches up. Question? Okay. All right, the last one here, what about that one?
No.
Because what am I missing?
The third side.
The third side. Now here's kind of a neat thing about when 2 triangles share a side. Okay? Would you agree that the BC for this bottom triangle, that distance from B to C, would it be the same distance as itself
Yes.
from the top triangle? Wouldn't BC be the same thing both time I measure it?
Yeah.
It's just not marked. So because BC is being used in both triangles, it's going to have the same length in both triangles, so it doesn't technically have to be marked. There's a property that we use. If we're ever doing a proof and we have to prove all 6 things are congruent, there's a property we use to be able to say that something equals itself, and that is called the reflexive property of equality. Says BC equals BC. So that's like the height of Miss Bishop is equal to the height of Miss Bishop. I'm the same height here as I am here. Hasn't changed, right? 5'2" in one place, 5'2" in the other place. Alright, so I can say my 2 triangles are congruent if I'm looking at my reflexive property of equality, which I can use. So triangle, what do you want to call the first triangle?
ACB.
A what?
ACB.
ACB? Is congruent to triangle. So if I started at A on my bottom triangle, then I'm going to start at D. And then from A I go to C. So from A I go across the 2 to the 3. So from D I'm going to go to B and then end up at C. Okay. My last question on this side of the notes says, if we wrote not possible, which we did for the second one, does that mean those triangles are not congruent?
Not necessarily.
Not necessarily. They might be congruent. They might not be congruent. I just don't have enough information. I just need those angles, right? So, no, they could be congruent. We need more information. They could be congruent. We just need more information. Questions? Okay. Number 1. Suppose triangle ABC is congruent to triangle DEF. So this time I'm not trying to check are they. They're telling me these are congruent. I know that angle A is the same as angle D. I know that angle B is the same as angle E. I know angle C is the same as angle F. I know segment AB matches with DE. I know BC matches with EF. And I know the outside letters AC match with DF. Okay? They're telling me they are congruent, so I know all that is true for this picture. It says to find the values of X and Y. So the first thing I like to do is say, okay, well, where is X? X is on this segment, which is segment what? EF. So segment EF is going to be congruent to, this is where my congruent statement comes in handy. Segment EF is congruent to which segment? BC. That was given to me by the congruent statement. Okay? So, BC is here. So if the segments are congruent, that means the distance from E to F is equal to the distance from B to C. E to F is 2x plus y equals B to C is 90.6. Now I have a problem, right? I have both an x and a y. So if I'm trying to solve for x, I need to know what y is first so I can plug it in there. So let's go see if we can find y. Y, where do I see a y other than in the 2x plus y?
Angle D.
Angle D. So angle D is congruent to angle what? Angle A, because they're both the first letter. So that means the measure of angle D is equal to the measure of angle A. Angle D is 2y minus 5. That's going to equal 65. What do I do first? Add 5, addition property of equality. 2y equals 70, and then what?
Divide.
Divide. And y equals? 35. So now I found y, I can plug it in over here and use that to help me find x. Two x plus 35 equals 90.6. What do I do first? Subtract 35. 2x equals 90.6 minus 35?
55.6.
55.6. Divided by 2. How big is x? 27.8. Alright, number 2. In this figure, angle A is congruent to angle C, angle D is congruent to angle B, segment AD is congruent to segment CB, segment AE is congruent to segment CE, AC bisects segment BD. Is triangle AED congruent to triangle CEB? What do you think I should do? Yeah, let's mark it up with all the information. Angle A is congruent to angle C. Arc mark, arc mark. Then, segment AD is congruent to segment BC. AD is congruent to CB. Check. What is the definition of bisect? Divide equally into two halves, right? When we bisect. So AC is dividing BD into two equal pieces. So look where BD is. Here's BD. AC is dividing it in half. So that means the left side is the same as the right side. Check. Using the definition of bisect. Angle D is congruent to angle B. D is congruent to B. And then, oops, I didn't check off that I marked it. Segment AE is congruent to segment CE. AE is congruent to CE. Do I have all three angles, all three sides? No, what am I missing? E. There's 4 angles at angle E. How can I tell that the two angles that are not marked, can I tell, are they congruent? Is there a way to know that?
Yes.
How do I know they're congruent? They're what?
Vertical.
They're vertical angles. Now, I can't say angle E is vertical to angle E, because they're two different angles. I can't call them both angle E. How can I name this one on the left?
E1.
AED. AED is congruent to, how do I name the other one? BEC. Because they are vertical. So is AED congruent to CEB?
Yes.
The triangles are congruent. Did you check to see if the order was correct over here? Or are you just saying, yes, the triangles are congruent? Let's check on the order and just make sure. A has a single arc mark. Does C also have a single arc mark? Yes. E has a trio, and E has a trio. We're good? So then we should be good. D and B both have double. So my answer here is yes. Because if they said is triangle AED congruent to triangle BEC, my answer would have been no, right? Because they'd have had, and a lot of times that's common. We'll say, oh, AED and BEC, because you'll try to start at the same spot. But notice this second triangle has been flipped over, right? The one on the top matches the one on the bottom over here. It's all been flipped, the second triangle. Yeah, it's been like reflected. All right. Let's look at these application problems. Again, they're telling me what my triangles are that are congruent. AB equals 6 centimeters, BC equals 10 centimeters, AC equals 11 plus x centimeters, DF equals 3x minus 13 centimeters, and DE equals 2y minus 5 centimeters. Find x and y. So the first thing I should probably do is label my picture with all its values, right? So I'm going to not worry about the centimeters because they're all centimeters, so I don't have to worry about changing any conversions. AB is 6. I'm going to mark that. BC is 10. AC is 11 plus x. DF is 13x or 3x minus 13. DF. DE is 2y minus 5. And that's all the information they gave me. Okay, do you want to find x or y?
Y.
Oh, we're conflicted. Anybody have a real strong opinion?
Y.
Y. Sorry, she was really excited about y. All right, so if we want to find y, y is on the segment from D to E. So DE is going to be congruent to, DE will match with AB. Notice I didn't just look at my picture and try to figure it out, because my picture may not be to scale. So I don't want to just go, oh, this one looks like the shortest side, so I'm going to match it with the shortest side. It happens to work out in this problem, but it's not always going to work out. Okay? So don't just use your eyeballs. Go back and use your congruent statement. DE, the first two letters match with the first two letters AB. If the segments are congruent, that means the distances are equal. Using the definition of congruence. So then we substitute DE
Y minus 5.
and AB.
6.
And then we just do algebra 1, right? It's just a two-step algebra 1 problem. What's the first thing I do? Add 5. So 2y equals 11. And then we divide by 2. And y equals 5.5. All right, so now let's go ahead and find x. So x is on AC. And AC is going to be congruent to which one?
DF.
DF. So that means the value from A to C will be equal to the distance from D to F. Okay? All right, AC is 11 plus X for substitution. Oops, I did not put my 11. And DF is 3X minus 13. What should we do first? There's 4 options. Subtract what? 11? Okay. So X equals 3X minus 24. Okay, then what?
Subtract 3.
Subtract 3X.
X.
So that's going to give me negative 2X equals a negative 24, and then
Negative 4X.
divide by negative 2. And X equals?
Isn't it negative 4X?
No, it's a positive X minus 3. Right? 12. Positive 12 is negative over negative. And you can check it if I put it in here. 11 plus 12 is 23. And if I put it over here, 3 times 12 is 36. And 36 minus 13 is also 23. So both of them come out to 23. Okay? Questions on that one? All right, 2 more. Triangle LMN is congruent to triangle RST. The measure of angle L is 50. The measure of angle M is 10y. The measure of angle S is 71. And the measure of angle T is x plus 9. Find x and y. So let's label our triangle with all of its values. Angle L is 50. Angle M is 10y. Angle S is 71. And angle T is x plus 9. Miss Bishop? Yes, I do. Okay, thank you. Bye. Brenda, you're heading home. All right. Okay, so when we look at this one, there you go. Did I get everything labeled? Yes, I did. Okay, we want to find x or y first. X. Okay, so angle x or x is at angle T, and angle T is congruent to which angle? Which one? N. Be careful, because this is one of the ones where it would be real easy to accidentally say it's equal to L, right? Because they'd both be on the left-hand side. But if I look up here, angle T matches with angle N. My second triangle has been reflected, right? It's been flipped over. So angle N, which means the measure of angle T is equal to the measure of angle N. And the measure of angle T is x plus 9. And the measure of angle N is, I don't know. So you know what? I'm going to skip it, and I'm going to go find y. All right. Let's find y. My y value is at angle M, which is congruent to angle S. Oh, good. We know that one. Okay. So angle S, the measure of angle M is equal to the measure of angle S. M is 10y. S is 71. Divide by 10. and y equals 7.1. Does that help me find n? No?
I mean, if you do the.
Do I know how big angle M is? Angle M equals angle S. Angle S is 71. Do I know how big angle M is?
Yes.
How big is angle M?
71.
Yeah, this one's 71. The matching one is 71. If I tear off these three angles and glue them together, what do they add up to?
20 degrees.
Can I find angle N?
Yes.
I sure can. Right? Because this angle L plus this angle M plus this angle N, if I glue them together, they're going to make 180 degrees like we did on Tuesday, if I were to tear those three corners off. 50 plus 71 is? So we subtract the 121 on both sides. Subtraction property of equality. How big is angle N?
59.
Alright, so that's helpful because now I know that angle N is 59 degrees. Yeah, I can find X. How big is X? How much? 50. Easy peasy. What if I wanted to find angle R? How big is angle R?
50.
Yeah, because R matches with L, and L is 50. So 50, 71, 59, 50, 79, or 71, 59. Okay? Everything matches. It's great. Triangle JKL is congruent to triangle MNP. JK equals 12 inches. LJ equals 5 inches. PM equals 2x minus 3 inches. The measure of angle L is 67 degrees. The measure of angle K is is y plus 4. And the measure of angle N is 4y minus 15. Find x and y. What's the first thing I should do? Yeah, let's draw a picture. And let's not make it hard on ourselves. Let's make the triangles look the same. So there's one triangle. There's my second triangle. And then I'm going to label them so that they look like they haven't been rotated or anything. So wherever I put the J, I'm going to put its matching letter M. Where I put the K, I'm going to put its matching letter N. Because since I'm drawing it, I can make it convenient. And then the L will match with the P. Okay. J to K is 12. L to J is 5. Oh, my picture's not to scale. That doesn't make sense. The little one's 12 and the long one's 5, but that's okay. PM is 2x minus 3. Angle L is 67. Angle K is y plus 4. And angle N is 4y minus 15. Do you want to start with x or y? Okay. So I see a y at angle K. And angle K is congruent to which angle? N. Which is going to be in the same position because I drew my triangle so that they're all in the same position. The measure of angle K is equal to the measure of angle N. Angle K is y plus 4. Angle N is 4y minus 15. What should I do first?
Move your y.
Move my y's. You want to move the little one or the big one?
The big one.
The big one? Minus 4y minus 4y. Y minus 4y's is negative 3y's plus 4 equals negative 15. Then what?
Subtract 4.
Yeah, let's subtract the 4 because if I add the 15, I'm going to end up with negative 3y plus 21 equals 0, right? We don't want that. So I'm going to, or 19. I'm going to subtract the 4 and get negative 3y equals a negative 19. Then what? Divide by negative 3. And y equals? 19 over 3 doesn't reduce. When you make it into a decimal, it's a repeating irrational decimal. It goes on forever and ever and ever and ever and ever. So I'm going to leave it as 19/3. I'm going to change it from negative over negative to positive because I'm going to simplify it by canceling out those negatives. But I'm going to leave it like this. If we do change it to a decimal, remember we should round it to 3 places. So we should do 6.333 if we do make it a decimal. All right, so now let's find x. I see an x here on MP. MP is going to be congruent to MP. Will be congruent to what? Okay, which one? JL. So that means the distance from M to P will equal the distance from J to L. The distance from M to P is 2x minus 3. And the distance from J to L is 5. What do I do first? Add 3. Addition, property of equality. Make sure you remember the terms because we haven't lost proofs. We're still going to be doing proofs. So make sure you still know all those terms. 5 plus 3 is 8. Now what? Division, property of equality. And x equals?
4.
Woohoo! Alright, so I do highly suggest if you don't have a picture to draw your own picture. And then remember, we learned the triangle sum theorem on Tuesday for a reason. So if I know 2 angles in a triangle, I can find the third, right? If I know 2 angles in a triangle, I can find the third. Alright, your assessment is in Schoology.